Okay, so now let us go to the second one. So now this is an example of automatic pipeline network construction using GIS shapefiles. GIS stands for Geographic Information Systems. And the shapefile, as I said, is nothing but a file with lines and dots. For example, I mean, in let's say Google Maps, it is composed of multiple layers, multiple shapefiles. You can, for example, switch off the actual map and look into the roads and the cities, lines, etc. So this is again a shapefile, all right? So it's layers of let's say lines and maybe colors, etc., that are on top of each other. So what I'm going to do now, I'm going to import a shapefile that contains pipelines, right, and connections, and I'm going to construct a pipeline network in PipeSim automatically. I'll click on Import Network. So this is the shapefile, .shp. And now when I click on Open, see what happens now. So now it found that the shapefile has certain, attributes, we call it. So we have pipe inside diameter, pipe wall thickness, right, and pipe roughness. So as you can see here, I need to override because the property is not available. So now what will happen is that, you see, it actually constructed my 2D network. And all these are new flow lines generated automatically from the shapefile. If I double click on the pipeline, I will see the horizontal distance, the latitude and the longitude, but I'm still missing the measured distance and the elevation. How can I import that? How can I generate that? Well, I can simply go to capture elevation. So automatically, when I click on capture elevation, PipeSim will go to the, for example, Esri service. In this, as you can see, data source is Esri, and it will find the pipeline profiles automatically from the internet. And this is free for all PipeSim users. Okay. As you can see here, now the elevation has been captured and also the distance. And all the red colors now is gone. However, pipelines are not connected to wells yet, right? Because the shapefile just has the start and the end of the pipelines. So now I'm going to save this network model, and I call it new model without wells. Okay. So now, as you can see here, I don't have wells. It's just pipelines. And now I have a network that contains only pipelines without wells. Okay. Next, I will show you the magic now. I'm going to automatically build well models using Python script from Excel. And then I'm going also to update the network model that I just created. And all the beginning of the pipelines, I'm going to place wells there. And all that without touching the user interface. Okay, let me do that. Sorry. Here we go. Sorry. So we have already developed a Python script for this purpose. So I have a Python script that will construct, that will build well models from Excel, from data in Excel. Okay. This script is launched through PipeSim using PipeSim Python plugin in Excel. This is the data, okay? We have wells, we have 20 wells, okay, that I'm going to build from scratch. I'm going to place them in this GIS location where I have the latitude, the longitude. I will use well templates, starting with well templates, and I'm going to update the data. Of course, this is not necessary, but this is for simplicity. So let me just show you the template. So I have a template. This template has already some data, some casing, tubing, completion, etc. So what I'm going to do is that I'm going to update each of the templates with data and then store it in the GIS location into my network model that I built in the previous slide. Okay. So I'm going to add electric submersible pumps. So these are the ESP properties. I'm sorry, it's a bit. So yeah, let me just, 1 second. So these are the well templates. And now we have 3 templates. We are going to add ESPs, electric submersible pumps. I'm going to change the phase ratio for the IPRs. I will keep the pressures. I'm going to add a plant as a sink in this location, and I'm going to add a check valve, okay, in this location. Now, let me just show you the script. So this is the script that is developed to build the models from scratch. Now, we are going to insert the original model name. So this is, as you remember, new model without wells. The video is without wells. And then I'm going to save it in a new name. I'm going to call it with wells, okay? This is the saved model. And now I click on this button that will launch everything in the background. And after a few seconds, the new model is launched. And as you will see now, all the wells have been added automatically without me touching the user interface. All the data came from Excel, right? ESPs have been added. Each well is placed in the right location because I defined the the UI, the UTM coordinates, the latitude and the longitude. Okay. So you can learn more. Okay, in PipeSim, if you download PipeSim, there is a number of videos and case studies. All right, and in addition to that, we have a very powerful step-by-step guide in the help system, and we also have a number of YouTube videos on Schlumberger official YouTube channel. We have also a LinkedIn PipeSim group that you can also be part of. And thank you. So let me ask Nikhil and Chata, do we have time so that I can do a live demo, or that's it?
Yes, sir, sure. We have a lot of time. You can go.
Perfect.
Yes, sir.
Okay. Before I go to the demo, anybody has a question? Do you want to type the question in the chat, or we can take
Sir,
live questions?
What we can do, sir, if anyone has any question, they can raise their hand and we will unmute you and they can directly ask questions with you.
Okay. So ladies and gentlemen, if you have a question, you can raise your hand through Zoom, and then we can, take it. Otherwise, if you have no questions, I can launch PipeSim now.
Okay, Mr. Ali, you can go ahead. You can ask your
Yeah, go
question.
ahead, please, Ali.
Hi, thank you very much for this great presentation. I would like to know the sort of differences or similarities. I see now the similarities between this PETEX software. We have this, from the PETEX package, Prosper, Gap. I see there are quite a lot of similarities. And what would you say that, okay, what we have in PipeSim was the difference from those packages?
Sure. So number one, PipeSim has the GIS integration. Okay. I will not, I don't think it's right that I let's say criticize or show any weakness of any other product for a competitor. Let me tell you the things that PipeSim has, and then you can find out yourself whether the other competitor has it or not. Okay.
Yeah.
So number one, PipeSim has the GIS integration. All right, where you can run models, you can look into the results gradient along the GIS. You can build networks automatically from the GIS and so on. So this is a very important feature. We also have our network optimizer or PipeSim network optimizer is unique in a sense that even the network simulation. So in the network simulator, let me just show you one thing here. If I go to the GIS map and then go to format. So as you can see here, this is the results gradient. Okay. One more important thing that PipeSim is unique about is that the whole network is is modeled in the same model. You don't have a separate software for the wells, another software for the network. Okay, so the well, if you want to model a well, it's in the same model. Just you can either double click on it right away, and it will open for you all the well simulation capabilities, literally everything. All right. If you want to model so this is the well, okay, and you can do all the simulation tasks in the well, right? You can switch from the home, you can go to the well perspective, and then the whole canvas, the whole software will focus on wells, okay, where you can run, for example, directly nodal analysis, all right, for the well, without actually affecting your network. Okay. One of the so this is the nodal analysis for the well itself, although I am in the same model, in the same network model. Okay. In addition to this, when PipeSim solves the network, including the wells, PipeSim do not rely on VLP curves. It doesn't, you don't need to construct outflow curves. You put ranges of the water cut, the GOR, the rates, etc. Because eventually the software needs to do interpolation. Okay, PipeSim network solver solves the whole network from the reservoir, from the completion, all the way to the separation facility. Everything in one model. Okay, so this is another unique feature, right? And there are also others like the availability of the 64-bit version, the ability of PipeSim in the cloud under Delphi environment, the ability, for example, to connect natively with Eclipse, which is our native, which is Schlumberger native simulator, and others. So and by the way, okay, that's it. This is an open. This is an open. I would say event, and I feel that my objective today is to show you PipeSim capabilities, and not compare it with any other product. I hope that's fine with you.
Yes,
sir.
definitely. I was not going to expect it to compare it. Thank you very much. Then, you know, this very great this capability you said, you don't generate the VLP curves that to interpolate. Then it's very interesting. How would you solve the network here then?
So that's the thing. So PipeSim has a very powerful numerical solver in the background that will consider the flow path. Let me show you. So I now have run the network simulation, right? So now if I go to the network simulation, I have what we call the profile results. The profile results starts from the well, right, all the way to the flow line, and I can even have a plot that will start from the reservoir along the tubing and then the flow line. Okay. Not only this, you can actually, if you have, for example, certain flow lines, you can let's say, let me just show you one nice feature. So here I have the network schematic. So you don't only have the GIS canvas, you have also the network schematic. Okay. Now, what if I want to show the pipeline, the pressure profile along all this path, right? Starting from this well. So we have well 4, and then we have this flow line P11, P12, P13, right? And then P16. So what I will do now, let me just show you again. Well 4, P11, P12, P13. So I go to the simulation results. Now I go to, let me just organize this. So I go to well 4. This is well 4. I put the control button, right? And then, okay, let me just check flow line. So this is between J4 and J2. So J4 and J2. I will hold the control button, click on it, and then I'm gonna continue. I will see J2 to J9. So J2 to J9. Here it is. And then I'm gonna also hold it until J9 to J1. So look what I have now. Okay, this is the pressure from the completion from the reservoir in well 4 until you can follow the path. All right, and then you can also compare that with all the wells that are connected to the same branch. Like, for example, if you have well now 5, all right, then between J5 and J4, you can do that as well, and you can have a very nice visualization for well 5. Like, for example, go here, and then you add again well 5. So this is well 5 now, and as you can see here, it is connected to the same flow line. So that's the beauty, that's the powerful, I would say, feature in PipeSim, where wells and pipeline networks are connected together. They're not separate. You don't model a separate, you don't need a separate software, a separate even license, a separate software to construct your well models. Everything in one integrated model.
Yeah, great. I believe it's just a tip from the iceberg, but thank you very much for your answers.
Absolutely. So, yes, another question.
Yes, sir, we have one more speaker. So, Mr. Emmanuel, you can ask your question. I'm unmuting you.
Good evening.
Hi.
Okay. The question I want to ask here is that in your node analysis, how can we be able to have access to, even though it's a demo PISys, a demo software, to be able to enable we that as fresh graduates to be able to follow along with the training?
So you know, the problem is that we in Schlumberger, we have a commercial model that we sell software to companies. Okay. Having demo licenses to individuals is very, very difficult, because we cannot manage. I mean, in each area we have what we call account manager, and this account manager is responsible for providing all the licenses. Our license system is very restricted, and if we really open it to individuals, it will be impossible to track. So unfortunately, this is not something that we can offer. But as I said, you can have, you can look into the videos, you can, learn from, from the help. I can share the help with you if you want. But and if you are part of a university, maybe the university already has a license.
Okay.
Sorry for that.
Okay.
No issues. Okay.
Yes.
Now,
Yeah.
Mr. Yang, I'm unmuting you. You can ask your question.
Okay, salute to everyone. I'm Yannick. My question is on the TypeSim and Olga. You
Yes.
mentioned Olga like a Gaussian simulation. I want to ask, on a practical point of view,
Yes.
what is the add-on from simulating with TypeSim and simulating with Olga?
Okay. That's a good question. So the objective of using both software is flow assurance. Okay, but you will find in any company, you will find what we call them flow assurance specialists, where they really need to look into not only the steady state conditions, but also the transients. Let me just explain. For example, if there is a pipe, if there is this trunk line here, right? You just zoom in. You have a well, and then you have this trunk line, and then you go to the field, and then you find that this well, if you go to the pressure gauge of this well, you'll find the pressure gauge is changing. All right, the production is isolating, right? So and then with time, you see that the production in this well is declining. All right. PipeSim cannot handle such scenario. You really need to go into Olga, which is the transient simulator, and try to simulate what is happening. You'll need to, maybe there is a, what we call it, maybe there is a slugging, maybe the flow is a sluggish flow and it's oscillating, right? And then it could die eventually. Maybe there is pressure waves coming in the reservoir. So all these things that are related to production dynamics, you need Olga to do it. Again, for example, if you want to really, let's say, design scraping, if you want, one of the pipeline management or pipeline integrity management practices is what we call pigging. All right. So pigging is a device, is a, let's say, an equipment that you inject, you insert within the pipeline, and then it will move along the pipeline, and it will clean, to swipe all the debris and so on from inside the pipeline. Olga will help you to design this pigging operation, the size, the timing, etc., etc. So that's why the PipeSim is used for overall production modeling, production optimization, whereas Olga focuses on trunk lines, on certain pipelines, for advanced flow assurance studies where the production dynamics is taken into consideration.
Okay, thank you.
Thank you, Mr. Yani, for your question, and thank you, sir, for your quick reply. So now, Mr. Anil Bansal, I'm unmuting you. You can ask your question.
My question is regarding the network simulation
Yes.
of the existing network. If
Yes.
some new wells are added, and then the simulation, and it may impact on the existing wells, so will reduce the reduction in the flow rates or some production from the existing wells. So
Correct.
how it will be like, because initially it was some production profile was there, and the year wise there are the different flow rates. So how it will be helpful PipeSim in handling that situation?
That's a very good question, and I promise you that I will answer this question in detail 2 weeks from now, because there we are going to talk about network optimization. But I will show you a glimpse. We have a functionality called Network Optimizer, in which you click on it, and then in the network optimization, you can put your optimization control. You can maximize oil rate, maximize liquid rate, and then you need to define what is your control parameter. Either, for example, choke beam size, if it's a gas well, or if it's an oil well, the ESP frequency, PCP speed, gas lift rate. And then you can put local constraints on the wells. Like, for example, you can go to certain wells and then you can define what is the maximum production per well. You can also go to the flow line level, and then you can, on the flow lines, you can define what is the maximum liquid rate, etc., etc. So all these are available, you know, to help you put you control your production in the network. And as I said, I'm gonna show you that in 2 weeks from now.
Okay, thank you.
Thank you, sir. Thank you, Mr. Anil, for your question. Okay,
Yeah,
so we will not take much question. We'll just take this last question by Hamai. So I'm unmuting you. You can ask a question.
Hi, good afternoon, sir. Very good presentation and a brief introduction to PipeSim. I just wanted to know about the Python toolkit. All the scripts are available with the Python in any handy toolbook or somewhere, or you need to develop on your own?
If you download, let me show you. If you download PipeSim, there will be a you know, a good number of examples that, let me show you. So here, if you go to the developer tools, then Python toolkit, then examples. There are tons of examples here, okay? Like, for example, it can be as simple as open close, right? So double click on it. And then, you know, I'm using VS Code as an editor for my Python. So where is it? It is, yeah. So this is an example. It says model open, model equals model open from case study, this one, okay? So as you can see here, I mean, there are a lot of examples. This is just one example. Another example is OpenSave, for example. And here we go. There is also some advanced examples, such as create network. Double click on it. You will see very detailed examples on how to do things. So as I said, there are tons of examples that can be used for you to start with, and then you can customize them based on your own need. So yeah, there are a lot of use cases here. Yes.
Okay, so thank you. And you can go ahead with the lecture.
Okay, so I think I'm almost there. So right now, as I said, we have two perspectives. We have the